Assalamualaikum and a very good day back to Prof. Azlan and everybody. My name is Nur Nabilah Nur Azelan with matrix ID of MCS201039. In this video, I will demo on how to perform genetic algorithm optimization using MATLAB optimization toolbox. And I will discuss the result based on optimum point of doses, minimal value of cases, GA parameters, and last but not least, the conclusion. Firstly, we need to extract the information from the question. So here we have objective function denoted as fx, the constraints x1 and x2, and from the constraints, we define the lower bound and upper bound of x1 and x2. We will define x1 as first dose and x2 as second dose, while the fitness value as y, which is denotes as the number of cases. And next, we have to define the process of GA optimization. But before that, let's take a look at the process involved. In genetic algorithm, the process involves our population initialization, a loop of parent selection, crossover, mutation, and survivor selection. And it will terminate and return the best solution. Now we are going to implement the GA process. Firstly, you need to define the objective function. So we will create a new script and insert the objective function. So this script will be called in the main script where we want to implement the main body of GA later on. So let's define the function as objective function and specify the input since we have two variables. So we will define two variables here and specify the objective function. So in MATLAB, I use the live editor in order to have the optimization task. So we need to click on the live script here. And here we will define the parameters that we need in order to run the genetic algorithm to find the best solution with minimal cost. So let's start with CLC, clear and close all, in order to clear a previous work if it is exists. And here we define the RNG as default. It is a command to control seed or starting point. So let's just set it as default. And we will define the constraint as lower bound and upper bound. So the lower bound will be the lower bound of x1 and x2, while the upper bound will be the upper bound value of x1 and x2. Starting with the basic output of GA, which is the minimal point, which denotes as x, and the fitness value denotes as f_val. So we will call the function that we have created just now. As you can see here, as we type in the parameter, a MATLAB will suggest the next required parameter. Next, we have the number of variables. Since we have x1 and x2 as variables, so we'll define the number of variables as 2. And in order to get the value of x and f_val, so we got here the result as x equals to 927.5 and 1019.6. And the f value obtained here is 3366.9. Okay, so we will compare the value after this. Now we'll try to add some more parameters to the GA, and we'll start with initialization. To define parameter, we need an option. We need GA option to use the GA and also some plots. We use here creation function that specify the function that creates the initial population for GA. What's value to input here? We can choose the GA creation linear feasible. This is the default value when there are a linear constraints and no integer constraints. This choice creates a random initial population that specifies all bounds and linear constraints. The next parameter is population size. It specifies how many individuals there are in each generation. With a large population size, the genetic algorithm searches the solution space more thoroughly. The next one is a selection of parents. So we use this option. This is a default selection function where it lays out a line in each parents correspond to a section of line length proportional to its scale value. Next parameter is crossover. So here we will choose crossover single point where it chooses a random integer n between 1 to n bars, our number of variables, and then select the vector entries numbered less n or equals to n from the first parent, and select vectors entry numbered greater than n from the second parent, and then it will concatenate these entries to form a child vector. Next, we will specify the crossover rate or fraction. So the fraction of the population of the next generation, it is not including the elite children that crossover function creates. So let's specify the crossover rate as 0.9 here. We can have the range of rates in between 0 to 1. The next parameter is mutation. So here we will choose the mutation adapt feasible. The default mutation function that there are constraints randomly generates direction that are adaptive with respect to the last successful or an unsuccessful generation. Next, we will set the number of iteration of generation produced. Here, I use 200 as iteration of generation. So before we run, let's specify more input here. We will add output and population, and then we need to add our upper bound and lower bound to our option, and also the variables option that we have defined just now. So let's run it. You can see the children are produced through iterations, and we have the results now. From the result, we can see that the value have been minimized than before, where the optimum points of doses, x1 and x2 variables, is obtained as 5,000 and 10,000, and the minimum value of number of cases, which is the y variables, is 3,222. With the variable discussed before, the GA parameter, which are chromosome, we use the random selection, the population that we specify to 200, and the crossover, we use single point crossover, and lastly, mutation, we use the mutation adapt feasible. Based on the result obtained after using genetic algorithm optimization, the minimum value of number of cases is 3,222, where the first dose x1 is at 5,000 and second dose x2 is at 10,000. Based on the calculated value using GA optimization in MATLAB, it is proof that the case can be lessened when second dose x2 reaches 10,000. The minimum value calculated in GA optimization utilizes parameters such as population, crossover, and mutation in order to have a larger area of search. The GA is run 2 times in order to maintain and confirm the best fit value calculated. With that, I will end my video on GA optimization using MATLAB. Till we meet again, thank you.